Hello everyone, we will be solving question 42 of GATE Chemical Engineering paper 2019 and the subject is heat transfer. The question is a solid sphere of radius 1 centimeter and initial temperature of 25 degrees Celsius is exposed to a gas stream at 100 degrees Celsius. For the solid sphere, the density is 10 raised to 4 kg per meter cube and the specific heat capacity is 500 joule per kg Kelvin. The density of the gas is 0.6 kg per meter cube and the specific heat is 10 raised to 3 joule per kg per Kelvin. The solid sphere is approximated as a lumped system, that is Biot number is very less than 1 and all the specific heats are constant. If the heat transfer coefficient between solid and gas is 50 watt per meter square Kelvin, the time in seconds needed for the sphere to reach 95 degrees Celsius is dash. So here we have been given a lumped heat capacity system in which we have to find the time taken by the sphere to reach the temperature of 95 degrees Celsius given all the other environmental parameters. Okay, so let's just write what all things we have been given. So the radius of the sphere is 1 centimeter. The initial temperature, we will call it as T0, is given as 25 degrees Celsius and it is exposed to a gas stream at 100 degrees Celsius. So let's just call the ambient air as T infinity as 100 degrees Celsius. And for the solid sphere, the density is 10 raised to 4 kg per meter cube. So let's just call it as density of solid as rho s as 10 raised to 4 and the specific heat capacity as 500. Similarly, the density of gas, let's just call it density of fluid as 0.6 kg per meter cube and specific heat of fluid as 10 raised to 3 joule per kg Kelvin. Now Biot number is very less than 1. So this implies that lumped heat capacity is applicable. The specific heats are constant and the heat transfer coefficient, so that is H, we have been given as 50 watt per meter square Kelvin and at temperature is equal to 95 degrees Celsius. Time we have to find. So all these parameters have been given. So from the lumped heat capacity, we know that the formula of the temperature varying with time is given as T minus T infinity, that is my ambient air temperature, is equal to T0, or T0 is my initial temperature of the solid body minus T infinity, and this will be equal to exponential of minus H A into Cp rho V into time, and this area is corresponding to the solid. Similarly, Cp is of solid, density is also of solid, and Vs is also solid. So we will be using this formula to find the temperature, to find the time taken by the sphere to reach the temperature of 95 degrees Celsius. Okay, so let's just calculate first this term, As upon Vs over here. So As upon, so the surface area of the sphere will be 4 pi r square, whereas the volume of the sphere will be 4 by 3 pi r cube. This will get cancelled out and this will be equal to 3 upon r. Now similarly, we will calculate the entire term inside the bracket, that is H A Cp rho s into Vs. So H we have been given as 50 into A by V, we have 3 upon R, and R we have been given as 1 centimeter. So let's just convert it into meter. So it will be 0.01 meter upon Cp of solid. Cp of solid we have been given as 10 raised to 4 and the density of solid we have been given as no Cp of solid we have been given as 500 and the density has we have been given as 10 raised to 4, so that will be 10 raised to 4 into 500. Okay, so we can simplify this and this entire term will be equal to 3 into 10 raised to minus 3. Now let's just put this value over here and we will get t minus t infinity on t naught minus t infinity is equal to exponential of 3 into 10 raised to minus 3 into t. Okay, and we will be having this minus sign over here. So now let's just replace the value of t naught, t naught and t infinity. It will become, we have to find the time taken by the sphere to reach the temperature of 95 degrees Celsius. So this will be 95. So let's just replace it. 95 minus T infinity was 100. T naught is the initial temperature, that is 25 minus 100. So this will be equal to exponential of minus of 3 into 10 raised to minus 3 into T. So this we can write it as 575 is equal to exponential of, we can take log on both the sides and that will give us ln of 1 by 15 is equal to minus of 3 into 10 raised to minus 3 into t. So we can solve this equation and we can get as 2.708 is equal to minus of 3 into 10 raised to minus 3 into t, and that will give us time as 902.67 seconds. So yes, the time taken by the sphere to reach temperature of 95 degrees Celsius will be 902 seconds. So yes, the final answer is 902.67 seconds, and since we have to round up till nearest integer, we can round it as 903 seconds as the final answer.